So in this video, we're going to look at how we can control stepper motors using the visual programming interface on the Seelab app. So I have the Seelab device here, and you see here is first there's a small stepper motor controller, which can drive more power because we're going to use CS1, 2, 3, 4 outputs of Seelab, and these cannot drive a lot of current. We're going to use these as signal outputs for the motor controller, and which is then going to control the motor. Now move to the app. Have the app open here. We make the connection to the app. Yeah, okay. Access Seelab. Okay. Now we're connected. So first we need to head over to the visual programming interface and create a new program. Now in the XPIs section, at the bottom you have init stepper motor and move stepper. So init stepper motor and we have two blocks here. First is the number of steps you want to take, 300. Second is the delay between each step. So that can be like 100 milliseconds. Take 10 seconds to take the whole 100 steps. Now for the connections. So the first set of connections that I've made are the inputs to the driver, which go to CS1, 2, 3, 4 respectively, these wires. Now we need the power supply, which ideally you should take from a separate source. For example, this motor needs a 5-volt supply. So you have the power supply pins. I'm going to just take that and use the Seelab's 5-volt itself because we're not going to drive heavy loads. So this is not recommended. And plug that in. So you have 5-volt ground and you have controller here and 4 input, and to the motor the controller will take care of the rest. Now what happens if I run this program? Okay, just 10 steps, nothing happened. It turns out I needed to make one more connection, which is this ground wire for the power supply. So I made the ground common. Let's take steps, the delay of 100 milliseconds between each, and on this. As you can see, the stepper motor is rotating. It's taken 100 steps. Take 10 seconds. 100 steps. What if you want to make it go back or to where it started? You can just say take 100 steps backwards. Minus 100. Now it's rotating in the other direction. And if you just want to make it go back and forth or move to a specified position, you can hit this block, 100 steps backwards, then move 100 steps clockwise direction. And the small little animation here that just shows you, which way the stepper is spinning and by how much. Although that's not going to directly correspond to the motor because different motors have different steps per 360 degrees. So while this little animation here shows 360 degrees, the motor, for example, takes one full turn in 200 steps. So it's going to vary from, but it's just a nice little indicator there. On this, you can see it's going to take 100 steps backwards. And the little animation keeps spinning here. And once it's completed 100 steps, it'll go back. This is your next block. So this can be used for a lot of experiments where you want fine control of moving certain things. For example, this motor featured here is a hollow shaft motor, which basically means you can see through the shaft. And that means that you can, for example, if you wanted to verify Malus's law, Okay, so Malus Law is basically gives you the relationship of light passing through a Polaroid and the uh, analyzer, and as you change the angle between the two Polaroids, there's the equation for the light intensity at the output. So what you can do is you can stick one Polaroid on one side of the stepper motor and the other on the shaft of the motor. You have the laser beam passing through. You can precisely set what angle the Polaroids should have between each other. And at the end, you can use a light intensity sensor such as the TSL25911 connected to the Seelab and write a small program to verify your Malus law, the I naught cos for theta. So I think we've covered what we needed to cover in this video. Thank you.